Unit 3, Lesson 3. What are we finding today? Today, the lesson is about finding the exact values of sine, cosine, and tangent. And specifically, how this is different from last class is last class we dealt with exclusively a unit circle. The radius was always 1. Today, we're going to look at what happens when the radius is not 1. The learning objective says beyond 1, but we could also do some things, some circles that have a radius smaller than 1 as well. So just basically, what are we looking at? We're looking at trig functions when the radius or the hypotenuse, if you wanted to apply it to a triangle, is not 1. So with that, let's get started. Recall from last class, I showed you this. In last class, we talked about that sine was y, cos is, tangent is, and there's a silent letter in there. That's the r. Specifically, last class, we talked about, well, if this was a unit circle, if r was 1, then sine would simply become what we said. Sine is y if the radius is 1. I should have done if r equals 1, then sine is y and cos is x. Now, tangent's always y over x, where x cannot be 0, it would be undefined there. Just recall this relationship. We're not going to deal with these until after the midterm, or I'm still not going to talk about cosecant, secant, and cotangent yet. But that's just a review from what we did last class. I want you to recall that before we go too far forward. Sine is y, cos is x. Today, we're going to look at stuff. What if r is not 1? Then I would just divide by my r. Okay, so here we go. It says here, the terminal side of an angle theta contains the point -5, 3. I'm going to pause here. -5, 3. That's telling you something, some mathematical values here. Specifically, -5 represents what variable? The x, Kevin. This is the x value, okay? What does the +3 represent? Y. Okay, so if you look at this graph here, notice that they have -5, 3 as an x and y value. It says find the exact values of sine, cosine, and tangent functions. Well, AP pre-calculus is all about the circle, not a triangle. So if you had walked into, say, a regular pre-calc class of mine, I would draw this as a triangle connecting to the nearest x-axis. For y'all, because that's focus in this class is circles, I want you to draw circles best you can, where this line here becomes what we call the terminal ray, or the terminal side, and I want it to be the radius of the circle. So draw your circle that goes through that point like that. Now I'm also going to extend this through the circle this direction, the initial side. So this is the initial side, this is the terminal side, like that. Because I don't want you just to not understand something that regular pre-calculus knows, if you were doing a triangle, your triangle would look like this. You take your point and you connect it to the nearest x-axis like that. Mathematically, this triangle I'm just putting up in green will give you the same values as what we're about to do using the circle. Okay, so that would be the relationship. It would be a triangle where this goes to the nearest x-axis, which means vertically to the nearest x-axis. That would be the triangle you'd use. Okay, so how do we do this? Well, there's a relationship on the previous slide. It said that x squared plus y squared equals your radius squared. This is the Pythagorean theorem, that your a squared plus b squared equals your c squared. So the Pythagorean theorem is what I'm doing here. So let's plug in or substitute our values. What do we know x is? -5. So I'm going to plug in a -5 there. And my y, what do I know about y? It's 3. We are going to square that. Now you may be wondering, why did I put a parentheses around -5 and now around 3? Well, that's because some of you use a calculator, and the calculator follows PEMDAS. Do y'all remember that saying, PEMDAS? And if you do not put a parentheses, the calculator will do the exponent. It'll square the 5 before it applies the negative. It calls that multiplication, negative and the 5. It thinks of that as multiplication, and so it'll square 5 first and get 25 and then make it negative, which is incorrect. We need to square -5. What is -5 times -5? 25. If you're going to use a calculator, you need to put a parentheses around the negative when you square it. Okay, what is 3 squared? 9. So the radius is going to be, the radius squared rather, is going to be 25 plus 9. What is 25 plus 9? 34. Okay, that's my radius squared. Now, to get the radius isolated, you have to get rid of the square. What is the opposite of a square? Perfect. So r is the square root of 34. Now, a radius is always positive. I'm going to point this out. X is not always positive. X is negative if you're on the left side of the graph. We're on the left side of the y-axis. X is negative. Y is negative if you're down below the x-axis. Y would be negative anywhere down here. Your R, or if you're looking at a triangle, your H is negative, never negative. They are always positive. So, can I reduce that? I'm going to start teaching you here. We have to check to see if we can reduce the square root. How you reduce the square root is like this. I use upside down division. I don't put the square root on. What you do is you take prime numbers that you know can go into 34. Can 2 go into 34? How many times? 17. Now, can 2 go into 17? Can 3 go into 17? Can 5 go into 17? Can anything go into 17? No, it's prime. That means it does not reduce. What this does is it tells you the square root of 34 is equal to the square root of 2 times the square root of 17. Problem is, nothing reduced there. So those two are one and the same, but nothing reduces. So I might as well leave it as the square root of 34. However, we're going to see some problems where this can reduce. For example, let's say we were reducing the square root of 29. This is just extra here. If we had to reduce the square root of, did I say 29? I meant to say 27. Does 27 have a square root? It does not, but I can reduce it. You can say, what number can go into 27? 3. 3 goes into 27 how many times? 9. And 9, you could just stop there. You could say the square root of 27 is the same thing as the square root of 3 times the square root of 9. So that would be the square root of 3 times the square root of 9. Can the square root of 9 be reduced? To what? 3. So that could be 3 square roots of 3. Does that make sense? We will be reducing square roots today. So you have to be on guard. This one does not reduce, does not simplify. Let me use the word simplify. This does not simplify. Square root of 34 does not. Okay, so after walking you through all of that, now we can write our answers. On the previous slide, we learned that sine was what ratio? Sine is y over r. What is our y? 3. So this would be 3 divided by square root of 34. Now, next rule for the day. We're not going to leave a radical in the denominator. It's called not rationalize. We're going to rationalize the denominator. Here's how you do that. Mathematically, you multiply by 1 to make it disappear. You say multiply by 1, that doesn't change the problem. You're right, it does not change the problem, but I'm going to make it a funny looking one. I'm going to multiply by the square root of 34 divided by the square root of 34. So quick math. If I'm multiplying by the square root of 34 and dividing by the square root of 34, what is square root of 34 divided by square root of 34? 1. I am multiplying by a funny looking 1. But what I'm not going to do is cancel. What I'm going to do is multiply straight across. Here I have 3 times the square root of 34. In the denominator, I have the square root of 34 squared. Notice it's the same thing multiplying itself, so it's the square root of 34 squared. Let me write it a little bit clearer for your notes this first time. What is the square root of 34 squared going to be? 34. There you go. That's how you rationalize it. Now, there's a shortcut you're going to hear me say throughout the school year. Whenever we have to rationalize our denominator, this is sine. I'm going to go ahead and circle it. That's your final answer. What you're going to hear me say when we have to rationalize the denominator is the shortcut I was taught. I'm a little bit older than you when I was in high school. The current phrase of the government you'd hear that was going on, it was the time of the war on drugs. And for whatever reason, every teacher we had came up with drug acronyms because apparently that was supposed to keep us from drugs. I don't know. It's kind of backwards thinking. But what I always heard was shoot it up. When you have a square root at the bottom, what do? You shoot it up. So I have the square root of 34 in the denominator. Look what ends up in the final answer. What happened to the square root? It got shot up. So the square root of 34 gets shot up to the numerator. 3 didn't disappear, so it's 3 times square root of 34. In the denominator, all you do is remove the square root. If there was a number in the front multiplying, you would still multiply them. This has no number in the front, so I just leave it as 34. That's the shortcut. So one more time. What's the shortcut if you have a square root in the denominator? Shoot it up. And from there, if you have to multiply, you multiply, but this time nothing happens. All right, we're going to do it again, and you'll get to see the shortcut again. Or not again, you'll get to see the shortcut for the first time. Let's try this. Cosine. Sine was y. What is cosine? X. So x is -5 divided by square root 34. Now, do we leave a square root in the denominator? No. What do we do with it? Shoot it up. Now, if you want to just go ahead and skip to your answer, but when you shoot it up, it should be -5 times the square root of 34 over 34. You got it. If you want to show all your math, you would multiply by the square root of 34 over the square root of 34, a funny looking one. And these two would be equal to one another. That right there. And so there's our second answer. There's cosine. -5 square root of 34 divided by 34. Okay, that was sine, cosine, tangent. Sine is y, cosine's x, tangent is, what is our y? 3, and our x? That does not reduce. That is as simple as it comes. There's our answer for tangent. So look back up at the instructions. You see how it says use radicals if necessary, but no decimals? What you will not be doing this unit is changing a square root to decimals. If you can change it to a whole number, like say, for example, the square root of 9 I had up here, then yes, change the square root of 9 to a 3. But if you have a square root of a number like 34 that cannot be simplified, you leave it. All right, let's go to example 2. It says, let theta be an acute angle such that sine is, what does acute mean in geometry? Less than 90 degrees. Okay, so here's the problem here. In AP pre-calculus, will you be tested using degrees? No, because that deals with triangles. We're going to deal with radians. If you remember, that is equivalent. Do you remember I taught you last class, if you had a circle and you started to go around that circle, how many radiuses in proper English did it take to get halfway around the circle? It took pi radiuses. Remember how that was pi radiuses? Pi radiuses, and so we called it pi radians to get around to there. That's how many it took to get to there. Now, how many degrees is it if you go half a circle? And so that was our equivalent statement, that 180 degrees is equal to pi radians. So now I'm back over here. I'm now working with half of 180. So if I'm working with half of 180 degrees, my radians would be half of pi, which we can say is pi over 2. So pi over 2 is here. This is 90 degrees, or pi over 2. 90 degrees or pi over 2. So the angle is going to be over here. It says sine is 5 over 6. Now let's think through the ratio. Sine is y, cos is x, tangent is y over x. I just told you, what is sine? This is giving you the y value and your radius. So the y value is 5 units. Go 1, 2, 3, 4, 5, and go a 6th. We want a circle. We want a circle as best you can that would go through the number 6 on the y-axis. And if you're like, wait, why 6? It's because, go there. And here's my initial angle. Again, I'm showing you this as a circle because that's what AP pre-calculus is all about. This would work for a triangle easier, but AP pre-cal does not want that. Now, I need to intersect my circle when y is at 5. So where do I stop? I'm going to add a little line to help me out. When y is 5 is where I intersect my circle. You see how it's about 5 right there? That's where I'm going to draw my line through. I'm going to say sine of 5, 6 is going to, that would be the angle there. So I'm trying to draw this properly so you can see how this works in mathematics. Now, why do I think triangle's easier? Because if you did a triangle, what you do is you would draw your triangle here, and we'd say, we know what y is. What's our y value? 5. We would know, instead of, you'll learn, if you were doing triangles, the radius is the same thing as the hypotenuse. The hypotenuse is 6. The only missing value you have is x. It's a lot quicker just to draw a triangle and say, okay, I got to solve for x. Either way, that's what we have to solve for. We know the y is 5. We know our radius is 6. What are we missing? X. We have to solve for x. And so the theorem that we use is the Pythagorean theorem. X squared plus y squared equals r squared, our radius squared. That's our formula we'll use here. Hey, Ruby, sit up for me, please. We don't know x, so I can't substitute that in, but I do know y. What is y? 5 squared, and we know our radius. 6. Okay, so x squared plus, what's 5 times 5? Or 5 squared? 25. Okay, what happened? My stuff froze up on me. Sorry, hang on. Not sure what's going on. Nope. Here we go. Okay. So we're saying x squared plus, what was 5 squared? And 6 squared? 36. All right, to simplify that, what's the opposite of adding 25? We're going to subtract 25 from both sides. And so x squared equals 11. Last step here in the process. What's the opposite of a square? Now, technically in mathematics, this could be a positive or a negative. You go off the picture. Is x greater than 0 or less than 0 if you're in the first quadrant to the right? Positive. That's where this came down to. The acute angle is allowing you to know that because it's the angle less than 90, we're on the right side of the graph, as opposed to if it had been greater than 90, we would have been over here and x would have been negative. So x is the positive square root of 11. Can I reduce the square root of 11? No, 11's prime. So here we go. Let's find the functions. They already gave us sine. Sine was 5 over 6. What will be cosine? Sine is y, cos is x. Square root 11 over 6. That's right. It's x divided by h. Let me go ahead and fill that in. That's the square root of 11. Sine is y, cosine's x. Tangent is y over x, which happens to be 5 divided by square root 11. Now, can I leave it that way? No, you can't leave a square root in the denominator. So what do I do with it? I'm going to shoot it up. You multiply it by a weird looking 1. And so it becomes 5 squared root 11, all divided by 11. There would be your answers. That's what it means by find the exact values. Do not use decimals. All right, you've seen me do this a couple of times. I'm going to let you try this. Now, before I leave you, It says that the angle is going to terminate in quadrant 3. What does that mean about x and y if you're in quadrant 3?
It's negative.
They're both negative. Now, heads up, because when you look at tangent, tangent won't show. What is sine is y, cosine is x, tangent is? It doesn't look like a negative and a negative. Why is it that tangent doesn't look like it's negative and a negative? If they're both negative on tangent, it would simplify, the negatives would cancel. But the true values are negative and negative. It needs to be a -4 and a -7 as you get going. That's truthfully a -4 and that's a -7 because x and y are negative. Okay, go ahead and work from there. You're looking for sine and cosine. DOL number 1. All right, let's connect this to geometry. Now, again, in pre-calculus, you're not going to be dealing with triangles, but for some people, it's very helpful to think in terms of triangles. You won't be tested on this. In geometry, you are looking at 2 triangles quite frequently called a 30-60-90 and a 45-45-90. Now, the reason we point these out, I say we as an AP teachers, because the unit circle is based off of these triangles. In geometry, they gave you this relationship, but I think in geometry, actually, they include an x on these. It's like they multiply all 3 sides by x. So it's x squared of 3, 2x, 1x. That's the side lengths, meaning x can be whatever number you need it to be. And on the 45-45-90 triangle, they would multiply that by x. And I think that would be the triangle you would get. It would be x. 1x is the same thing as just x, and x squared of 2. I think that's the way they give it to you. Well, the relationship without the x's is what appears on the unit circle. That's where our unit circle gets the values. So the angles 30, 45, and 60 will occur frequently in our course. And I should have added in a 90 degrees. 90 is included in those. But we use radian measure, pi over 6, pi over 4, and pi over 3. And in the case of 90 degrees, let me do 90 degrees. It's equal to pi over 2 as well. We're going to see those. All those values occur on the unit circle. We're going to see it here. When I say unit circle, I'm talking about this. Did we use this in your class last time? Oh, no? Okay, well, I'll show you how it works today. You won't get this on the AP exam. You won't get this resource, but I'll show it to you in a little bit. Okay, so here we go. So this says, we did use that on the 3-2. Y'all just forgot. We used it.
We drew it. There we go.
Yeah, okay. So it says complete this table below using special right triangles on the previous slide. If you're watching this video in the future, you can go ahead and pause the video and use this. I'm going to do a different thing in this class now. Let's pause this video. All right, so filling this in, I'm going to use the radians. Let's look at the palm of our left hand. Pi over 6. Which finger is pi over 6? Then your ring finger. When you flip your hand over, how many Y fingers do you have? 1. So it's going to be the square root of 1 over R. R is always the square root of 4. So I'll write it here, but I won't in the future. Okay, before I reduce that, skip over to cosine. Sine is Y. Sine was Y over R. What is cosine's ratio? X over R. How many X fingers do you have at that same location? 3. And R is, again, square root of total fingers are 4. Okay, sine is Y, cosine's X. What is tangent? Okay, how many Y fingers do you have right now? And how many X's? Okay, now we'll reduce these. Square root of 1. What is the square root of 1? 1. What's the square root of 4? So it's 1/2. Over here, on cosine, you cannot reduce the square root of 3. But I can reduce the square root of 4. What is the square root of 4? 2. And then here, I can reduce square root of 1, but the biggest problem is the square root of 3. I don't leave that in the denominator. What do I do with that? You shoot it up. So it's the square root of 1 times the square root of 3. What's the square root of 1 times the square root of 3? Square root of 3. And then on the bottom, it just becomes 3. There you go. Those are my values. All right, we're going to reload and do this again. Ready? Pi over 4 finger. Which one's your pi over 4 finger? Middle. Bend your middle finger, flip your hand over. How many Y fingers do you have up on top? And for radius, it's always just going to be 2. Your radius will always be 2 when you use your hand trick. Okay, how many x fingers do you have? And again, radius is always 2, so I'll just fill in the 2. All right, so here, tangent, I have how many y's? Divided by how many x's? 2. Now let's reduce. Okay. Cannot reduce this. Can't reduce that. What is the square root of 2 divided by square root of 2? 1. Yeah, those stay, those don't reduce. All right, last one, pi over 3. Looking back at the palm of your left hand. You always look at the palm of your left hand like it's the first quadrant. Which finger is pi over 3? Index. Bend it, flip it. How many y fingers do you have there? Square root 3. How many x fingers do you have there? Square root 1. It's always the square root of fingers. And then tangent, sine is y, cosine is x. Tangent is square root of 3 over square root of 1. Okay, we go to simplify. Can I simplify the first one? No, it's already simplified. What about the second? 1 over 2, and then square root of 3 over square root of 1. I would say shoot this up, but what is the square root of 1? 1. What's the square root of 3 divided by 1? There's your value. And here I put a note. Again, if you were doing 0, which finger would you use for 0? Pinky. And if you were using pi over 2? Thumb. And you would do it the same way. All right. So here it says find the values for sine and cosine for each of the given angles. So first let's start with pi over 3. It says to find sine of pi over 3, then cosine of pi over 2 minus pi over 3. So let's start with sine of pi over 3. If I wanted sine of pi over 3, which finger would we bend? Looking at the left hand, which finger would you bend? Which one's your pi over 3 finger? Index. And if you're narrowly lost, if you filled out the last table, you can just look back at the table. Bend your index finger. Flip your hand over. How many y fingers do you have there? Square root 3. Now, for your radius, it's the square root of total fingers. It's the square root of 4. What's the square root of 4? 2. We get square root of 3 over 2. That's our value. Sine and cosine will always be divided by 2. We haven't done the thumb or pinky, but those, when you bend the thumb or pinky, will reduce, and the 2 will seem like it disappears. But it's always divided by 2. Yep. Okay, now let's do cosine. But it says take pi over 2 and then subtract pi over 3. Now, we don't have fingers for that. So we need to do a little, I don't know, 5th grade. Combine some fractions here. What's the rule to combine by subtracting fractions? Same denominator. So to change my denominator, what's a factor that 2 and 3 both go into? 6. The easiest way, if you don't know, is just multiply the 2 numbers together. They go into 6. That means the first fraction needs to be multiplied by 3. It needs to be multiplied by 1, excuse me. But it looks like 3 over 3. I'm going to multiply both top and bottom by 3 on the first fraction. The second fraction, what do I need to multiply on that one? 2. So again, it's a weird looking 1. It looks like I'm multiplying by 2's. I'm actually multiplying by 1 because 2 divided by 2 is 1. Now we can simplify that and come up with our values. This would equal cosine of this. They both have a denominator, 6. What's 3 pi minus 2 pi? 1 pi over 6. Okay. So now, look at your left hand. We're looking for pi over 6. Which finger was our pi over 6 finger? Ring. Bending your ring finger, flip your hand over. We're looking cosine. Cosine is x. How many x fingers do you have there? So it's square root of 3 over 2. The square root of 4, which becomes 2. Now tell me, what do you notice about our 2 answers here? They're the same. Pi over 3 is the same as pi over 6. Oh, wait, I said that wrong. Let me try that again. Sine of pi over 3 is the same thing as cosine pi over 6. That's a correction. There we go. Pi over 3 is not equal to pi over 6. Sine of pi over 3 is equal to cosine of pi over 6, though. I didn't have to have that parenthesis there, but it's there. So let's try this again. We get to do the thumb. I gave it away. What's your pi over 2 finger? Your thumb. We're going to do the thumb this time. All right. Let's start with first sine of pi over 2. So looking at your left hand, you bend your thumb. Flip your hand over. What do you get for y? 4 fingers. So it's the square root of 4. What is our r always going to be on the hand trick? 2. Because it's the square root of total fingers. And if you bent 1, you should have 4 standing up. So square root of 4 can be simplified. This is 2 divided by 2. And 2 divided by 2 is 1. Okay, great. Now let's find cosine. It says find cosine of pi over 2 minus theta, which in this case, theta is pi over 2. So this will be easy math here. It should be. What is cosine of pi over 2 minus pi over 2? 0. So we're going to be looking for the cosine of 0. I don't have to put a parenthesis, so I won't. Cosine 0. Actually, just because 0 can look so weird, I will put that in parentheses. Cosine of 0. All right. Which finger is our 0 finger? Pinky. Anything without a denominator is your pinky. Then your pinky, flip your hand. How many x's do you have there? 4. So it's square root of 4 over, what is r? 2. Oh, we've already had this. We had it right here. What will that reduce to become? 1. 2 over 2 becomes 1. Notice my answers here. That sine of pi over 2 is exactly the same as cosine of 0. What can we learn here? We can learn a relationship called a cofunction. Here's the cofunction relationship. That if something's a cofunction, then, which sine and cosine are, you hear how it says cosine, sine, cosine. They are cofunctions. What does that mean? That the sine of any angle is going to be equal to the cosine of the pi over 2 minus the angle. Pi over 2. This is where I really wish we could work in degrees because it's easier to understand degrees. Pi over 2 is equal to how many degrees? 90. Cofunction means that they're complementary functions. Complementary. What does complementary mean? Geometry. The angles add to 90, they are complementary. They're complementary functions, meaning as long as the two angles add to 90, or in this case, add to pi over 2, then sine and cosine would be equivalent to each other. If you have two angles that combine to be pi over 2, then sine and cosine would be equal to each other. Same thing with tangent and cotangent, or secant and cosecant. I'm going to show you one more little cool deal I made. Go for it. I'm going to show you something real quickly. Did I show you where the trig functions got their names last class? All right. Well, I'm going to show you here. I added in a circle so you can. Well, here's the circle. Let me shrink this down. Okay. Where does everything get their name? On a circle. There's a circle. You looking at that circle? There's only one point that I want you to look at on this circle. Let me zoom in. Just won't let me zoom in. Let me zoom in up here. Zoom in. Not working like I thought it would. There's the only point I want you to focus on is this point of tangency. That's the only one. Okay, you remember for unit 1, we said a tangent line is a line that only touches a curve how many times? Once. Okay, so this line right here, this green one, is a tangent line. That is a tangent line from unit 1 because it only touches a circle one time. What is the value of tangent? Tangent is from the point of tangency to the x-axis. If you measured that, that's what tangent is. You know how we said sine is tangent is y over x? Now, mathematically, that's the same thing. But how did they come up with it originally? Tangent value was from the point of tangency to the x-axis. They said, hey, let's call that tangent. Now, do you know what they called the other end that connects to the y-axis? Not sine. If this is tangent, they call this one cotangent. So tangent connects to x, cotangent connects to y. Okay, I'm gonna do this again. This time from this point right here. Now let me go back. Yeah, I'll do this. I'm gonna go in order. Mathematician said this: a secant line. Do y'all remember secant from earlier in the year?
Yes.
It's a line that would cut through a shape twice, not just once, but twice. So if you think of like the diameter that would cut a circle twice, the secant line starts at the origin and it's representing kind of like a diameter cutting through the circle twice. The secant line goes from origin to the intersection of the tangent and x-axis. It goes from here to here. Now that's what we call a secant. Well, what if we went this way? What do you think they called that one? If this is a secant to the x-axis connection, what do you think they call it if they connect at the y-axis? Cosecant. That's what the cosecant is. Okay, one more. The name sine, I think it's in Latin, means to connect. Sine connects the tangent, because that was the only word we didn't do unit 1. We had a tangent line. We had a secant line. We did not have a sine line. What is a sine? What does sine mean? Sine means to connect. Sine connects tangent to secant, which is on the x-axis. What do you think you call it if you connect it on the y-axis? Cosine. So let me walk you through this again. What is this value called right here? Tangent. What is this value called? Cotangent. What's this one called? Secant. What's this one called? Cosecant. What is this one called? Sine, and this? Cosine. Mathematically, you could draw a whole lot of similar triangles, which we don't do because we don't do triangles, and you would learn that these same values out here, if you came and brought them inside the circle, would be x, y, and r's. That sine would be the y value, this y value, divided by the radius. It's the same value. This sine right here, the length of that would be the y value divided by this radius, because this radius is 1. So this y value divided by 1 would give you that length. The cosine would be the x value, because you can see it's x. The tangent is the y, this value, divided by the x. That would be mathematically the same as this if you did similar triangles. It's an amazing thing, but that's how it works. Do you need to know about those triangles, though? No, but that's where the names come from. I hope you were entertained. I spent about 45 minutes programming that little circle just to show you. I didn't even move it around. This is true for any circle. I'm going to just move it over here. Okay, what would you call this line that connects from the point of tangency to the x-axis? What do we call that? That's tangent. Tangent connects to the x-axis. The main ones connect to x. That's tangent. So what's this dash green line to the y? Cotangent. This is sine connecting to x. So what is this connecting to y? Cosine. This is the secant going this way. So what would you call it on along the y-axis? Cosecant. You got it. Tangent to touch, secant to cut, sine to connect. Tangent touches the point of tangency. Secant cuts the circle. Sine connects the tangent to the secant. That's where the names came from. If you're wondering where did they come up with these weird 6 names, there they are. All right, let's go back to the lesson. That was all free. You don't even have to pay for that part of the lesson. Your DOL, though, you have to pay for. All right. I want you to do this DOL because I don't want you to be ignorant of degrees. I've included degrees. Looking at your hand, we've been saying thumb is pi over 2. Now, what would that be in degrees? 90. Because pi is 180. What is pi over 3? What is 180 divided by 3? So your pointer finger, your index, is 60-degree finger. 45, 30, 0. You got it. So this is just like the special right triangles. You have a 90, a 60, a 45, 30, and a 0. Okay? Go ahead, solve those as quickly as you can. All right, picking back up. And if you struggle on that using a hand trick, you can look back on the table from earlier today. We had the values written there, and you can plug them in to come up with your values from that table. Example 4. It says, given the measure, an angle measure of 4 pi over 3 in standard position. Now, one more time, I don't want you to forget, what does standard position means? It means an angle that originates, at the positive x-axis. Let me do this over here. An angle that originates at the positive x-axis. So this angle began there, and it traveled. Remember, pi is a count of radiuses. 4 pi over 3, that's a count of radiuses. It traveled 4 pi over 3 radiuses to get to there. That's what's going on right now. So we went around this circle 4 pi over 3 radiuses. Does that make sense? That is 4 pi over 3 radiuses. That's what that is right there. Now, normally we just put the angle on the inside like this and say theta is 4 pi over 3, but I'm just reminding you where pi comes from. It's a measurement of radiuses around a circle. Pi would be halfway around the circle in radiuses. So 4 pi over 3 in standard position with a circle with a radius r. Go ahead and add that. Centered at the origin. Find the coordinates of point P here. Okay, now this is very, very simple. I'm going to take a relationship I already gave you today. So I'm solving for x first. So this is not normally the order we usually start with sine, but I'm going to start with cosine. What is the relationship for cosine? Cosine is what? Just x or over the silent r. Today, we need that silent r because r is not 1 on this problem. What is r? 5. So here's what I could say. I'm going to plug this in and say cosine of, what's my theta? 4 pi over 3 equals x divided by, what's our r? 5. To solve for x, which is what I need right here, I need an x and I also need y. How can I get the x isolated? We will multiply both sides by 5. Okay, so this is going to give us our x value. I'm going to have 5 times, this is the first time we've gotten to do a 4 pi over 3 angle. Look at your left hand. Which finger is your pi over 3 finger? Which finger was the pi over 3 finger? Index. Spin your index finger. I know it says 4 pi over 3. We'll get to that. Flip your hand over. I'll go ahead and put this just in parentheses. We're looking with your index finger bent over at the back of our hand. How many x fingers do I have for cosine? 1, and you divide that by 2. Now, looking at the graph, now adjusting on this graph, here's the x-axis. Is this to the left or to the right? Do I have a positive x or a negative x? Negative. This is a negative value in there because I'm on the left side of the origin. That's the origin. That is 0, 0. Since we're on the left side, we have a negative x. So this is going to be the value of x. So I'll just multiply. What is the square root of 1? 1. So it's 5 times negative 1. Negative 5, and that will be divided by 2. Now let's go find the y value. How could I find the y value, do you think? Sine. We're going to use sine. Sine theta is y over r. So let's plug in our values. What is our theta? 4 pi over 3. I wrote cosine. Oh my goodness. Let's try that again. Sine is 4 pi over 3 over, or equals, y over, what's our r? 5. What's the one step of math I need to do to solve this, to get this y isolated? Multiply both sides by 5, and now I can simplify. So this will be 5 times, okay, let's go back to which finger was our pi over 3 finger? Bend your index, flip your hand. How many y fingers do you have there? So a square root of 3 over radius of 2. Now, do I have a positive y or negative y at 4 pi over 3? A negative. That would equal y. So when I simplify that, what do I get for y? Well, nothing simplifies. So I'm just going to have negative 5 times the square root of 3. You do not multiply something outside a square root into a square root. You don't do it that way. So negative 5 square root of 3 all divided by 2. So what's the position of that point? That point is negative 5 halves, comma, negative 5 square root of 3 divided by 2. That right there is the unit circle value just multiplied by 5. I'm going to pull that out. I want to show you this on the unit circle so you can see this. There you go, grab her. Here's 4 pi over 3 right there. This is 4 pi over 3. Here's its point right there. Notice our answer is so similar. The only thing different from a unit circle is how you use a unit circle. Is you find 4 pi over 3, but you multiply by the radius. What was our radius? 5. And so all you had to do is multiply this point by 5 to get your answer. That's how you use a unit circle, why it's so effective. All right, deal number 3. It says here, let theta be an angle in standard position. That means it originates from the x-axis with point P, which is xy, a point on the terminal side. That means the graph ends right there. And r equals x squared plus the square root of x squared plus y squared. It wants to know what's the value of sine, cosine, tangent. Now, do I have any numbers here? No. So I want ratios. I want you, by memory, to give me what sine is, what cosine is, what tangent is. Give you a hint. This is what I'm saying to you all the time by song. What is sine? What is cosine? What is tangent? Just give me the ratios, and you'll have completed your DOL. Example 5. It says if theta terminates in quadrant 2. What does terminate mean? Ends. So what you need to know is when we talk about a circle, we're always going to start at the positive x-axis. That's the initial side. Terminal means ending. It ends right there in quadrant 2. And cosine is -1/3. Now let me show you how this works. You should know by ratio, what is cosine always equal to? X over r. Now r by rule has to be positive. So our radius here is 3. I'm going to solve this like a triangle because I think it's so much easier that way. As a triangle, what you do is from the terminal point, you go directly to the x-axis. You always go not to the y, you go to the x-axis. This is called a reference triangle. In case you take calculus later on, beyond AP pre-cal, if you hear reference triangle, that's what they mean. They took a circle and they made it a triangle by going directly to the x-axis. Vertical to the x. There it is. I know my radius is 1. I now also know what is my x value. -1. Now on a triangle, if you were actually a triangle, you would make, you only deal with positives, but on a unit circle, we'll have negatives because this is the x-axis and this is the y-axis. So x is -1. That means I'm on the left. It has a length of 1. I have to find the y value. Do we know y? We don't know y, so we have to find it. What's the relationship between x, y, and r? I heard Pythagorean theorem. That's it. X squared plus y squared equals r squared. In this problem, we know what x is. What is x? I'm going to put it in parentheses for the sake of PEMDAS. Y, we don't know. Oh, we do know r. What is r? Let's do a little math. What is -1 times -1? So we have 1 plus y squared equals 9. Very good. We subtract our 1 from both sides. What does y squared equal? 8. Now, what's the opposite of a square? A square root. So typically, in unit 1, we talked about if you add a square root that's not originally there, it needs to be a plus or minus. This unit, you shouldn't have pluses or minuses because you should be able to, from a circle, determine if it's a positive y or a negative y already. Will this be a positive y or negative y? Positive. But I can reduce the square root of 8. Let's do a little upside down division. If I took the 8, what's a prime number that can go into 8? And 2 goes into 8 how many times? Now you can actually stop there if you want, because truthfully, this is the square root of 2 times the square root of 4. Do we know what the square root of 4 is? Yeah, so I don't have to keep going because I know I can jump and say, oh, that's 2 times the square root of 2. All of that is equal to the square root of 8. 2 square roots of 2. Which happens to be our y value. 2 square root of 2. Okay, so it says find sine. What is sine's ratio? Okay, we just found out y is 2 square roots of 2. What is our r? 3. Do I need to rationalize the denominator or am I good? You're good. That's your answer. All right, part B. Let's try this again. It says if tangent is 4 pi over 3 and cosine is less than 0. I'm going to pause. Sine is y, cos is x, tangent is. So this represents the y. This represents the x. However, like your DOL earlier, they could have been reduced. They could be a -4 and a -3. We don't know yet. This says cosine is less than 0. What is cosine? X. Truthfully, cosine is x divided by r, but there's a rule about r. R is always greater than 0. So if I did my math here, if I multiply both sides by r, because this is positive, the inequality will not change, which means this, x, what is 0 times r? 0. X has to be less than 0. Which side of the graph are we on? We're on the negative side. We have to have a -3. But if I put a negative there, I change tangent. What's the only way I can keep tangent being 4 over 3? But if x is actually -3, make 4 negative as well. We have a -4 and a -3. So I'm just going to guess that this will be roughly somewhere in here. I'm going to say that this is -3. So if that's -3, let's call that -2, that -1. So we'll call that -3. And this is going to be -4. So I don't know, I'm trying to space this out evenly. 2, 3, 4 like that. That'll be -4. So now to draw it properly, here's your standard position. Your angle always begins, the initial side, the initial ray is on the positive x-axis. Terminal goes through that point at -3, comma -4. This point right there is represented by -3, comma -4. If you want to look as a triangle, where's your triangle always connect to? The positive x-axis, just directly up above like that. Okay, we went through all of that. What am I missing right now? We have our x. X is -3. We have our y. Y is -4. We do not have r. So what's the formula to get r? Okay, what is our x value again? -3. I'm going to put it in parentheses so that PEMDAS, if you're using a calculator, doesn't mess you up. Y is -4. We'd square that. What is -3 squared? -3 times -3? 9. What is -4 times -4? 9 plus 16 is 25. And final step here, what's the opposite of a square? Square root. Again, in unit 3, we won't have pluses or minuses. You should know a r is always positive. So r is the positive square root of 25. What is the square root of 25? 5. So r equals 5. We need to know sine and cosine here. So what is sine's ratio? Y over r. So it'll be -4 divided by 5. And then cosine's ratio. Sine is y over r. Cosine is x over r, which happens to be -3 divided by 5. Neither of those reduce, so those are your answers. One thing I did not add here is this would be your theta there. I didn't add that to the diagram. I'll go ahead and do that now. That would be the theta right there. All right, DOL number 4. Now, I told you by rule, what is always true of r? R is positive. What's the only way to multiply by a positive and get 0? Multiply a positive number with something else and get 0. What's the only way to multiply and get 0? You have to multiply by 0. I want you to think through what are all the places that you could get cosine being a 0. I would use your hand. Think of it backwards. What are the only places where you could have 0 cosine fingers? Think of that. All right, DOL number 4. One here. Example 6. Machine shop needs to drill through a steel plate at point P here. Calculate the measurement for the placement of the hole, then use your calculator to approximate the location of the drill bit. So here, I need to know x and y. How can I find my x? What function does x? And this is given a r. What function finds x? Cosine. So cosine of 25 degrees will equal your x divided by your r of 14. Before we type this in the calculator, what's the only thing needed to do to isolate x? Okay, now there's going to be one thing we'll do also for the y, but I'm going to go ahead and get this answer in the calculator. What you need to make sure you do on the calculator is you need to change your mode up in the top. Mine says radians. Your cell phone, whatever you use by default, is radians. You'll need to click it and switch to degrees to get the right answer. 14, there's a button that says trig, you press cos of 25, and that's how you'll get your answers there. And now, just if we wanted to complete this here, to get the cosine, there's only one step difference. So if cosine is x over r, the sine, when we find our sine, it will be the y divided by r. So the y divided by 14 is degrees. So one more time, same steps. We're going to multiply both sides by 14. And in your calculator, just make sure you're in degree mode. That's the key here. Make sure you're in degree mode. So 14 trig sine 25 degrees. That's my value there. I will copy these over. And that would be our, once we put it together as a point, this would be our solution here. And let's see, it says approximate. So I'll go to nearest tenth here. I'll say this point is roughly 12.7. I'm going to approximate 12.7 comma 5.9. Okay, that would be my value there. Okay, now I have one more DOL for you. All right, so as you look at this problem here, DOL number 5, I'll let you work on this. And just for the sake of your drawing, this angle right here represents pi over 3, in case you want to use your fingers. And this angle over here represents 2 pi over 3. You can use a unit circle. That's ugly here. You can use a unit circle, or you can use your fingers to help get you the answers. Pay attention to which quadrants you're in and what the values should be. And also one more thing, your radius is 10. Don't miss that. So remember, if you use a unit circle, you need to multiply your values by 10, just because of the ratio. So anyways, you want to know, what is the distance between the 2 points of the intersection? What you're looking for is, what is the distance from here to there? What is that distance? That's what you're trying to figure out.